Hello, I'm Tom Nahumi from Dell EMC. In the previous demo, I introduced Project Karavi, which aims at improving the observability, usability, and data mobility for stateful applications with Dell Technology Storage Portfolio. In this video, I'll be focusing on the integration with RedHat OpenShift and demonstrating a real user experience of monitoring cloud-native application connected to cloud-native database, both running on OpenShift cluster connected to Dell PowerFlex storage system. In order to simplify the deployment and manage the entire lifecycle of Dell CSI drivers, we've released the Dell CSI operators. From the OpenShift console, we click on Installed Operators, and then we can see that the Dell CSI operator is already installed on our OpenShift cluster, including Grafana and Prometheus operators, which can be easily installed via the Operator Hub. In addition to these operators, I installed Project Karavi using Helm and configured it to send the PowerFlex performance metrics to Prometheus. This project brings capacity and performance metrics collections as well as basic storage topology by pulling the data from the storage array and the CSI drivers and sending it to Grafana and Prometheus, community-driven open source tools which became the de facto standard for collecting and visualizing various Kubernetes ecosystem metrics. Now, if we navigate to the Networking tab and clicking on Route, we can access the Grafana dashboards. By clicking on the Karavi dashboards, we can see that a very low I/O is running on the system. So let's run some load. For the purpose of this demo, I deployed an instance of YugaByteDB, which is a high-performance cloud-native distributed SQL database. This database consists of 3 master and 3 worker nodes, each connected to a dedicated PowerFlex persistent volume, which has been created and mapped from the PowerFlex cluster using the CSI driver to the OpenShift worker nodes. This database has a very useful web UI, which allows us to monitor the database performance and operations and visualize the different components. In addition to the database, I deployed a sample e-commerce application called Yuga Store. This microservices-based retail e-commerce app is composed of microservices written in Spring, UI based on React, and YugaByteDB as a distributed SQL database. Now, I'm running a load tester which mimics the behavior of an end user at a very high rate in order to monitor the performance in each and every layer. By navigating to the YugaByte UI, we can see the distributed write and read operations running on each YugaByte worker node. If we navigate to the PowerFlex UI, we can monitor the health and performance of the entire storage system and examine different elements as well as provision and modify many of the PowerFlex front-end and back-end components and features. Project Karavi provides us with the missing piece between the two: in-depth visibility into the Dell EMC CSI driver provisioned volume characteristics correlated with volumes on the storage system. Using these built-in observability dashboards, we can get visibility into the I/O performance metrics, IOPS, bandwidth, and latency by Kubernetes node or by persistent volume object. We can see live and history data, filter by specific object, change the time frame, and create our own customized dashboards. Together with the new PowerFlex HTML5 UI, Karavi Observability provides us end-to-end performance monitoring solution for OpenShift cloud-native applications running on PowerFlex, from the PowerFlex storage building blocks to the application persistent volumes. For more information, you can visit the official GitHub page and the Dell container community. I really hope you find this demo useful, and thank you very much for watching.